Hello everyone. So today we're going to solve LeetCode problem number 3129. Find all possible stable binary arrays. Right. In this questions, we are given three integers. So 0, 1, and limit. So it is saying that the binary array is stable if the array in the array, right, occurrence of 0 is exactly 0, occurrence of 1 is exactly 1, and take any subarray of the array. The length greater than limit must contain both 0 and 1. So these are three conditions we have. And here you can see that we have to return the number of binary arrays and answer may be very large. So we have to return it to modulo of 10 to the power 9 plus 7. So let's take a look into some examples. So in the first example, we have 0 equal to 1, 1 equal to 1, and limit equal to 2, right? So for this 0 equal to 1, 1 equal to 1. So we have only two possible arrays, this one and this one, 0, 1. And zero, both the array length is not exceeding limit, right? So these are two uh, like answer. So here we have output as 2. Let's look into the second example. So here we have 0 equal to 1, right? And we have 1 equal to 2, and we have limit equal to 1. So here, if you see, so we have three possible binary string. One is 1, let's say 1, 1, 0. Another is 1, 0, 1. After that, we have 1, 1, 1. So here, if you see, we have limit equal to 1, right? So in the third condition, what is saying is subarray with size greater than limit, right? So greater than limit means our size is 2. Size equal to, we are interested in size 2 and more than that, right? So let's for this one, for this first example. So if you see here, we don't have any 0. So this is not a valid, right? For this one here, for the third example, in the last two, uh, for this subarray, right? We don't have any 0. So this is also not valid solution. But here, this is a valid solution. So this is a valid solution, right? So the answer is 1. So answer is 1. So we have another example. So again, like we can iterate through this example and we can find out this as a, for this example, we are going to have 14. So how we're going to solve this, right? So here, the main thing is like we have, so let's, what we have, like we have 1, then we have 0, right? After that, we have a limit, right? In the brute force approach, what you're going to do is like, what you're going to do is like, here uh, for a binary string, how many characters we are going to have? We are going to have here n equal to 1 plus 0, right? So this is going to be the length of the resultant array, each and every array, right? So in the uh, brute force approach, what you're going to do here is, so for each character, right? So you are going to add either 0 or 1, right? Till you completed adding like 1 plus 0 characters. Once you finish this, so once the length become your 1 plus 0, right, you're going to check the third condition. And how you can check that third condition? Just using a sliding window. Just using a sliding window, right? Just using a sliding window. Let's understand with this third example. So here, if you see, we have 3 and 1, right? 1 is 3, right? Limit is 2. So we have 0 is given as 3, 1 is given as 3, then our limit is 2, right? So here, if you see, what I can do is like first I can add 30. I'm just doing the brute force. Initially, I am adding 10, 20, 30. After that, I'm adding 1, 1, 1, right? So now my length is 6, right? Now what I'm going to do, I'm checking this for the third condition. So as limit is 2, right? So we are interested size 3, right? Size 3. So here I'm going to take a window of 3. So initially I'm taking here 3. Here I'm find out that there is no 0, right? No 1, sorry. 1. So this is not a correct answer, right? So again, what I'm going to do is like I'm going to brute force this one. So 0, 0, 0. So I'm going to 1, 1, 0, right? So here also, if you see initially, I'm going to here. This is also not a sorry. So for first window, this is the window, right? Here also it's not a valid, right? That condition is not satisfying, so this is not a valid string. So this way we can progress. But if I'm taking one of this, let's say after that I'm building this one, 100, 101, right? So let's say after doing all the recursion, if I'm building 100, then I think what is it? It's 101, 101. So for the binary string, if we are going to check whether it's satisfying the third condition or not, right? So let's put a window here. Is it satisfying? So we have both 1 and 2. So this window is satisfied, right? For this window, yes, it is satisfying. For this window, yes, this is satisfying. For this window, it's satisfying, right? So we can say that this is a valid binary string, right? Binary string. This is a valid binary string, right? Uh, so if I'm doing this by brute force approach, right? So what is our time complexity? So here, if you see, for each and every position, right, I have two options. So I have kind of like I have how many numbers, right? I have the length of the binary string is you can say length of the binary string is 1 plus 0, and for each and every character I have two, you can say I have two options. So 2 to the power 1 plus 0, right? Again, like for each and every string, what I'm doing here is I am like doing this sliding window operation, right? So for that also, like I have 1 plus 0 operation I'm doing. So this is going to be my time complexity. This is my time complexity, and space complexity is like the heap of the recursion tree, right? So here, if you see, right, so this is too much. So if you're going to implement this solution, so it will going to give you TLE. So how we can solve this problem, right? Let's understand like how we can solve this problem in dynamic NDP. So as this is a binary string, right? Let's say whatever string we are taking, right? The string can be end with either 0, right? Either 0 or 1. So these are the two only possible, right? So this possible. So let's take another base case. Let's say we have 0 equal say 0, and let's say 1 equal to some number n, and let's say limit is greater than n, right? So for this case, what you can say is like our answer is always going to be 1 because we have to fill with only one only, right? So you can do multiple permutation here. And vice versa, what you can say is, let's say 0 is equal to n and 1 is equal to 0 and limit is again like same condition. For this also our answer is 1 because here if you say we have to take only 0, 0, 0, 0 till till n at 0, right? So for both this condition, so the answer is always 1. So this two is, you can say these two are our base case. Base case, right? Base case. So after that, what you can say here is, uh, what you can say here is, so let's say we have some random number, right? Our random length, let's say we have here, we have 0 equal to z, right? And 1 equal to, let's say, oh, right? So if let's say for this length, right? If what we have two condition is either it can ends with 1, right? Or either it can ends with 0. If let's say it ends with 0, right? So we have something here, right? Before that we have something here. After that we have 0, right? Here ends with 1. Here we have something here and here we have. So after that we have 1, right? So here what you can say here is whatever combination we have before, let's say z minus 1, 0, right? And you can say we have 1, 1, right? Whatever combination we have, that's going to be answer, right? And here you can say whatever combination we have for z 0 and o minus 1, 1, right? Uh, that is my answer, right? So if let's say if we want to store each and everything, so what we are storing here is how many zero we have used, right? How many zeros, how many ones, right? How many ones and ends with, right? Ends with. So we have kind of like three parameters to track. So obviously we have to go for a 3D, 3D matrix. 3D matrix. So in the 3D matrix, right? So it's going to the matrix size will be. So our, you can say our dp is going to be some int, right? So first one is like we have size is going to be 0 plus 1. Then we are going to have 1 plus 1. Then we have 2. So this 2 will indicate like whether we are ending the uh, whether we are ending the, you can say ending the substring with 0 or 1. 0 or 1. Okay. So our base case is this one, right? Base case is this one. So you can say like till, so our dp of z comma 0 comma 0 is going to be 1 for how much, for where z is less than or equal to limit, right? And our dp of 0 0 of 1, you can say 1 1, here we have 1 equal to 1, or you can say 1 is less than equal to limit, right? But after that, what going to happen here is, you can say here we have already uh, defined. Uh, let's take a stage when we have, let's say, you can say we have zeros equal to z, and once is equal to, let's say, 1, right? Okay. So at that point, we have two situations, right? Either what you can say is like either the binary string is ends with 1, or either it can ends with 0. So if let's say the binary string is ends with 0, right? So for this situation, so what we are going to have is z, then we have o, right? If we are saying that it's ends with 1, right? So 1. So for that, what we're going to have is like 1, right? So last index is 1. So before that, what can be happen is, so we have already completed, we have already put it all the z's, z number of zeros, right? Only thing is left with o minus 1. So previously we put like o minus 1 once, right? Either it can end with 1, right? Or either it can end with, you can say, dp of z, you can say 1 minus 1, and either it can end with 0, right? So this is the simple condition, or it can end with 0 as well, right? So for that, what is going to happen here is, so if it is ends with 0, then we are going to have is dp of z, dp of 0, and dp of 1, right? It can end with, so here, as, sorry, this is going to be 0. So if it is ends with 0, so previously what happened, right? We have already placed z minus 1 zeros. Uh, so we have already placed all the ones, right? Either it can end with 1, or either it can end with 0, 0, right? So for a simple condition, this is summation of these two will us uh, give us the length. But let's say z plus o is greater than limit, right? Greater than limit, right? For this, you can say, for this one, this is not going to be answer, right? Somewhere, so whatever we have to sliding into, right? So there will be some combinations. So where we have to, it is going to file at the third condition, right? Third condition. So how we are going to find that violation, like how many combinations you have to remove, right? So let's take an example, right? So let's say we have limit equal to 5, right? Limit equal to 5. No, no, sorry. So our total length is, let's say, 5. So equal to o plus z equal to 5. And limit equal to, let's say, our limit is equal to 2, right? So let's take an example. So let's say our array is ending with, let's say 0, right? So we have something like 1, 0, 0, 1, 0, 0. Length is so 5, right? So length is 5. So let's take a random array 101, 0, 0. So what we have is, so as limit is 2, so our size is 3, right? So what you have is, so whenever there is size 3, right? So we have to make sure if, let's say, so if you look into the size right here, so here if you see, we have both, right? We have both 1 and 0. So this is a valid, right? But if you say for this window, we have either zeros or either 1, right? So then this is not going to valid, right? And we have to minus those combination. So how we're going to find this find find this combination, right? So you can say, right? So here for any, like, let's say we have let's take example again here. So what I'm saying here is, so I have z number of zeros and one number of like O number of points, right? So for this one, so whenever we are ending with zero, whenever I am ending the binary string with zero, right? So if I'm saying is, so if I have already put z minus size of zeros, right? Z minus zeros, size of zeros already, right? And after that, what happened here is z, let's say at one index, let's take a one index x, right? Uh, X index. So X is nothing but your, you can say O plus Z minus size. So what I'm saying is, if at the position I have already using Z minus X, and I'm saying that I'm putting something uh, O X of one, right? Right, and that is like ending with one, right? Ending with one. That ending with one, right? After that, you can say after that till our O plus Z index, right? O plus Z index, but I can put only zeros, only zeros. So, so whatever I have in the end, right? If I'm taking, so I have something like 0, 1, 0, something, something, something. After that, in the end of the window, right, of size, here I can put only zeros. There is nothing else I can put. Let's understand with an example. So let's say our let's understand here only, right? So according to this one, our size is 3, right? So what I'm saying is there is something x. So here I'm already using z minus 1 size. So here for this one, I'm using 0, right? And x equal to 0 plus size, 0 plus o, z plus o plus size. So here index is equal to, you can say is how much your size is 2, right? 2 minus 2, 2 minus 3, 1. So something like I have, it is the index is going to be 1, right here. So I have already using two ones here. And after that, it's ending with 1, right? It's ending with 1. Ending with 1. So after that, what you can say here is, if I'm taking anything after that, right? So what I can do here is I can take only use this one, right? I have 3 zeros left, so I can use only 3 zero after that. So you can say this, I have to remove this combination, right? So what you can say is, so for anything, so for any length which is greater than the limit, so here you can say if array is ending with 0, then what I have to do here is like 0, you can say uh, 0, it's ending with 0 is equal to, you can say dp of z 0 of 0, then you can say is minus, you can say minus, you can say dp of z minus limit minus 1. Then we have here, we have put all the zeros here and all the ones here, and it's ending with 1, right? So we have to minus this portion. Similarly, we can write for 1 as well. If it is ending with 1, so it's z of, it's 1. So here it's going to be dp of z of 0 of 1, right? 1 minus, you can say is dp of z, right? It's 1 minus limit, then sorry, I'm going to write it here. I think it's not covering in the screen. So dp of dp of z. So I have utilized all the zeros. Then 1 minus limit minus 1. And it should be ending with 0. Right? So this portion I have to minus. So this is high level like how we're going to progress in dynamic programming. So if you look into this time complexity, right? So for each and every z, we have to check all the zeros, right? So you can say our time complexity for this dp is the time complexity here is 1 into 0, and the space complexity because what we're doing here is uh, so we are taking like 1 plus so 0 plus 1 into 2, right? So it's kind of like 1 plus 0 matrix. This is going to be again n square complexity. That's it. Let's take a look into the code. So let's start coding for this solution. So first thing is like we need a mod, right? So because we have to take a module of this. So our mod is equal to 219. So 3060207. So after that we need a DP. So as we discussed, it's going to be our 3D DP. So this is our DP. So let's initialize the DP. And it's going to be 0 plus 1, then we have 1 plus 1, then another is by 2 because we have already discussed, right? We have to maintain, we have to track, right? So whether the array is completed with 0 or 1. So let's write down the base condition. So these are our base condition. If the array is only it has only zeros, right? And it's we have only a single combination. And if it is ending with only one, so then also we have a single combination, right? So after that, the main part comes, right? So let's write a like write for this one. So here our z is going to be start from 1, right? And z is going to be less than or equal to zeros. Why? Because here, if you see, right, we are using one index, right? So zeros and our z plus plus, right? And after that, we can say is uh, for for in the, o equal to 1, then o is less than or equal to 1, so it's 0, right? 1 to the o plus plus. So for that, right? So after that, what we have here is, so if dp of we have z zeros and o ones, right? And if it is ending with, let's say, 0, right? So here, for this one, what we're going to have is, so let me copy this so that we don't have to, so plus, right? So either we have z minus 1 zeros, right? And it's ending with 0, or either we have z minus 1 zeros or ending with 1, right? So this is going to be uh, the answer if let's say size is not exceeding our limit. So after that we have to do mod here. If let's say our total size is limiting the limit, exceeding the limit, means how I can check it, z minus limit, right? -1 is greater than or equal to 0, right? What we have to do is like we have to minus minus the portion for which like we have using only zeros, right? So for that, what we can do here is, let me copy paste from here only. So here uh, we have here initially we have calculated this value. So z1 zeros, then we have to minus it. So what we have to here is, as we discussed, it's going to be limit -1, and it's you can say 0, and it's going to end with a 1. But what we can have here is this value can be greater than this one. For that, this is going to be negative. And whenever we are doing a mod of negative, right, we are going to give kind of like you can say uh, plus. First thing is like to get the correct answer, we have to add a mod again. Then we have to take the mod. So to handle the negative value, so we have to add a mod here. So after that, similar way, so we have the same thing for if it is ending with 1. So for this one, you can say is we are already utilizing all the z's, only we have remaining with only 1. So either this could be value or this, right? So we have already utilized all the z's, right? Only single one is left, so that's why it's o minus 1. So if 0, right? So what you can do here is here z minus 0, it's ending with 1, right? It's ending in 1. So you can say is ending with 1. So you can say is z is going to be there, but it's ending with 0, right? So this is the one. After that, what we have to return is we can return our dp of 0, 0, then dp of 1, we can say 0, plus here you can say we have to return 1, right? And after this adding also, this can be exceed uh, our mod value. So we can add a mod here. So let's run it. So we have all the test cases are succeeded. So let's submit it. Yeah, it's passed. So we have bit 93.42. So I think this is the optimized solution. Yeah, that's it for today. So see you in the next video.